Day 13 of 90, and today we crack the one concept that quietly powers every event handler, debounce, and React hook you've ever written: closures. Here's the bait: this React counter alerts 0 every single time you click it, no matter how high the count goes. The state is updating. The alert is lying. By the end of these 5 minutes you'll know exactly why, and you'll stop guessing at async bugs forever. A closure is just a function that remembers the variables around where it was defined. When that broken counter runs setCount, count +1, then setTimeout equals alert, count 3000, the timeout closes over count. But here's the trap: it closes over the binding from that render, not a live value. 3 seconds later it reads the count that existed when the function was created, 0. The function didn't capture a number. It captured a variable. To see why, picture the scope chain. Every function has a chain of environments it can reach, its own block scope, then the function that wrapped it, then global. When you read count, JavaScript walks up that chain until it finds the name. Our alert finds count in the render where it was born, a render that's now gone, frozen in memory. That frozen environment is the closure. Nothing magic, just a function holding a reference to its birthplace. This is the same bug as the classic loop. For var I equals 0, I5, I++, setTimeout equals console.log, I prints 5 times. Why? Var is function scoped, so all 5 callbacks close over one shared I. By the time they fire, the loop finished and I is 5. Swap var for let and it prints 0 through 4, because let creates a fresh binding each iteration. Same closure mechanic, different bindings. You closed over a variable, not a value. Once that clicks, you stop fighting closures and start using them. Watch this node HTTP server. I create a database connection once, outside the request handler, then http.createServer, req, res, equals db.query. Every request closes over that same DB. The connection persists across requests without a global, without a class, it lives in the closure. That's not a workaround. That's the pattern behind connection pools, caches, and rate limiters in real production code. Closures also give you genuinely private state. Here's memoize, a function that takes another function and returns a wrapper closing over a const cache equals new map. Function memoize fn, const cache equals new map, return n equals cache.has n, cache.get n, cache.set n, fn n.get n. Nothing outside can touch the map, it's sealed inside the closure. Wrap a recursive Fibonacci and you go from exponential to instant. The cache is private, the API is one clean function. That's encapsulation with 0 classes. Scale that idea up and you get the module pattern. An IIFE, an immediately invoked function, runs once, declares private variables, and returns an object of public methods that close over them. Const counter equals, let count equals 0, return, inc, equals ++ count, get, equals count, outside code calls counter.inc, but can never reach count directly. Private state, public interface, the whole module system is just closures wearing a nice suit. So when you hit a stale closure bug, a listener reading old config, a hook alerting an old value, don't cargo call to fix. Trace the scope chain. Ask one question: what binding did this function close over, and when? If the answer is an old render or the var from before the loop ended, you've found it. The fix is almost always giving it a fresher binding, a let, a ref, a getter, so it reads the value at call time, not birth time. Day 13 done. Closures capture bindings, not values. Read the scope chain and async bugs stop being mysteries and start being obvious. Subscribe for day 14.